The artillery crews said, no gun can reach that distance, 35 kilometers across the Nevada desert beyond the range of their massive M777 howitzers. 12 veteran gunners had tried and failed, their shells falling short in the endless expanse of sand and rock. Then she stepped forward with her calculator and said quietly, I can make that shot. What happened next shattered every artillery record in US Army history and redefined what was mathematically possible. From which city in the world are you watching this video today? If this story resonates with you, consider subscribing for more tales of unrecognized heroes. Her name was Specialist Rebecca Sterling, and she was exactly 4 months into her first assignment at the Yuma Proving Ground Artillery Range in Arizona when the impossible challenge was issued. The sprawling desert facility, covering over 1,300 square miles of open terrain, served as the Army's primary testing ground for long-range artillery systems and ammunition development. The morning sun was already beating down on the concrete firing positions where 6 M777 155 mm howitzers sat in perfect alignment, their massive barrels pointed toward targets that stretched across the desert horizon. Each artillery piece weighed over 9,000 pounds and was capable of hurling 95-pound shells over 30 kilometers with devastating precision under normal circumstances. Colonel William Drake stood on the observation tower overlooking the firing line, watching through high-powered optics as another artillery round fell short of the designated target. As the senior artillery officer at Yuma Proving Ground, Drake had overseen thousands of firing exercises, but today's challenge was pushing the boundaries of what even he considered possible. "Miss, 800 meters short," the range safety officer reported over the radio, his voice carrying the disappointment that had marked the entire morning's efforts. The target in question was a decommissioned tank positioned at exactly 35.2 kilometers from the firing line, a distance that exceeded the maximum effective range of the M777 howitzer by over 5 kilometers. The challenge had been issued by General Patricia Morrison as part of an experimental program to test the limits of conventional artillery systems. Master Sergeant Carlos Hernandez, the senior fire direction control specialist with 15 years of artillery experience, stepped back from his computer terminal with visible frustration. "Sir, we've calculated every possible variable: wind speed, atmospheric pressure, temperature gradients, Earth rotation. The physics just don't support a hit at that range." Standing nearby, Staff Sergeant Michael Torres, who had served 3 combat deployments as a gunner, nodded in agreement. "Master Sergeant's right, sir. We're asking these guns to do something they weren't designed for. Even with maximum charge and optimal conditions, we're falling consistently short." Rebecca Sterling stood at her workstation in the Fire Direction Center, a modest trailer filled with computers, ballistic calculators, and communication equipment. As the junior member of the fire control team, she was responsible for basic calculations and data entry, while the senior specialists handled the complex ballistic computations required for long-range artillery fire. But Rebecca brought a unique background to her military service that her personnel file didn't fully capture. Before enlisting, she had completed a mathematics degree with a focus on applied physics and had spent 2 years working for a civilian ballistics research company that developed advanced projectile systems for aerospace applications. "Specialist Sterling," Hernandez called out, "input the data for attempt number 13. Same parameters as before, but increase the charge by 2%. Rebecca dutifully entered the numbers into the ballistic computer, but her mind was working through calculations that went far beyond the standard artillery tables. She had been observing the failed attempts throughout the morning and had noticed patterns in the data that suggested the conventional approach was fundamentally flawed. The 13th attempt produced the same result as the previous 12, a shell that fell short of the target by several hundred meters. The massive howitzer recoiled with thunderous force, sending a shockwave across the desert floor, but the distant explosion confirmed another miss. "That's it," Colonel Drake announced over the radio. "We've exhausted all reasonable approaches. The target distance exceeds the practical capabilities of this weapons system." As the artillery crews began securing their weapons for the day, Rebecca reviewed the morning's data on her computer screen. The ballistic solutions had all been technically correct according to standard artillery doctrine, but they had failed to account for several environmental factors that could significantly affect projectile performance at extreme ranges. "Master Sergeant," Rebecca said quietly, approaching Hernandez as he shut down his equipment. "I think there might be another approach to this problem." Hernandez looked up from his paperwork with the patient expression of a senior NCO dealing with an enthusiastic junior soldier. "Specialist, we've tried every variable in the book. Sometimes you just have to accept that a target is beyond effective range." "Yes, Master Sergeant, but what if the book is incomplete?" Torres overheard the conversation and joined them with obvious skepticism. "Sterling, we've been doing this for over a decade. The ballistic tables account for every factor that affects artillery trajectory." Rebecca hesitated, knowing that challenging the expertise of her senior colleagues could be career-limiting, but her mathematical analysis suggested possibilities that standard doctrine didn't address. "Sergeant, the ballistic tables are based on average atmospheric conditions and standard projectile behavior. But at extreme ranges, there are micro-environmental factors that become significant." Hernandez frowned. "Such as?" "Upper atmospheric wind layers, thermal inversion effects, and most importantly, the cumulative impact of Earth's rotation over extended flight times. The Coriolis effect becomes exponentially more significant as range increases, but our calculations are treating it as a linear variable." Torres shook his head. "Sterling, the Coriolis correction is built into the firing solution. We're not missing that." "We're correcting for it, but not optimizing for it," Rebecca replied. "At 35 kilometers, the projectile is in flight for over 2 minutes. During that time, the Earth rotates enough to create deflection patterns that compound with atmospheric effects in ways that linear calculations can't predict." Master Sergeant Hernandez studied Rebecca more carefully. "You're talking about advanced ballistic theory that's beyond standard artillery doctrine. Where did you learn about atmospheric layering effects?" "I studied applied physics before enlisting, Master Sergeant. I worked on projectile dynamics for a civilian research company that developed long-range delivery systems." The conversation was interrupted by Colonel Drake's voice over the radio. "All stations, prepare to conclude exercise. We'll submit our findings to General Morrison with the recommendation that the target distance exceeds practical engagement parameters." Rebecca made a decision that would define her military career. "Master Sergeant, request permission to attempt one more firing solution." Hernandez looked at her with surprise. "Specialist, we're done for the day. The Colonel has called the exercise." "I understand, Master Sergeant, but I believe I can calculate a solution that will reach the target." Torres stepped closer, his expression skeptical. "Sterling, you're 4 months out of basic training. You think you can solve a problem that experienced artillery specialists couldn't?" "I think I can approach it differently," Rebecca replied steadily. "The conventional methods treat this as a standard gunnery problem with extended range. But at this distance, it's actually an aerospace trajectory problem that requires different mathematical models." Hernandez considered her words. Rebecca had consistently demonstrated exceptional competence with ballistic calculations during her brief time at the unit, and her work was always precise and insightful. More importantly, she was suggesting a fundamentally different approach rather than minor modifications to existing methods. "All right, Sterling," Hernandez said. "You've got 30 minutes to show me your calculations. If they make sense, I'll request permission from the Colonel for one more attempt." Rebecca immediately began working on her computer, pulling up atmospheric data, wind measurements, and projectile specifications. But instead of using the standard artillery ballistic programs, she opened a civilian aerospace trajectory modeling system that she had quietly installed on her workstation. "What software is that?" Torres asked, looking over her shoulder. "It's a ballistic modeling program designed for satellite launch vehicles," Rebecca explained as her fingers flew across the keyboard. "It treats the projectile as a small spacecraft and calculates optimal trajectory based on real-time atmospheric conditions rather than standardized tables." The program required detailed inputs that went far beyond standard artillery data. Upper atmosphere wind speeds at multiple altitudes, temperature gradients throughout the projectile's flight path, barometric pressure variations, and precise Earth rotation calculations based on the exact time of firing. "Where are you getting all this atmospheric data?" Hernandez asked, watching as Rebecca input dozens of variables that weren't part of normal artillery calculations. The proving ground has a weather monitoring system for rocket testing, Rebecca replied. It provides real-time atmospheric readings up to 50,000 feet. I've been correlating that data with our firing results to understand why the standard calculations aren't working. After 25 minutes of intensive computation, Rebecca's program generated a firing solution that was dramatically different from any of the previous attempts. The recommended trajectory was higher and longer than conventional artillery doctrine would suggest, with timing and directional corrections that seemed counterintuitive. Sterling, this solution calls for maximum charge plus 15%, Torres said, reviewing her calculations. That's beyond safe operating parameters for the M777. The weapon can handle it safely, Rebecca replied. I've checked the technical specifications. We're still within structural limits, just beyond standard operational doctrine. Hernandez studied the detailed ballistic projection that Rebecca's program had generated. The mathematics were complex and sophisticated, involving calculations that he recognized from advanced engineering courses but had never seen applied to artillery fire. This is way beyond anything I learned in fire direction school, he admitted. But the math looks solid. Let me talk to the colonel. 5 minutes later, Colonel Drake's voice crackled over the radio. Fire direction, this is the colonel. I understand you have a new firing solution proposal. Yes, sir, Hernandez replied. Specialist Sterling has calculated an alternative approach using advanced ballistic modeling. Request permission for one final attempt. There was a long pause before Drake responded. Master Sergeant, we've already exceeded our scheduled firing time and I've got a report to write explaining why we couldn't reach the target. What makes you think this will be different? Sir, Specialist Sterling is using ballistic software designed for aerospace applications. Her approach treats the extreme range as a trajectory problem rather than an artillery problem. Another pause. All right, you've got one shot. But if this doesn't work, we're done for the day. Rebecca's hands were steady as she made final adjustments to her firing solution, but her heart was racing. She was about to test mathematical theories that challenged decades of artillery doctrine using methods that no one else at the proving ground fully understood. Gun crew, prepare for firing, Hernandez announced over the radio. Firing data. Charge 7 plus 15%, elevation 52 degrees. Deflection left 180 mils. The gun crew leader's voice came back immediately. Fire direction. Confirm that charge. You're asking for 15% over standard maximum. Confirmed, Hernandez replied. Charge 7 plus 15%. The artillery crew loaded the howitzer with the specified charge, an amount of propellant that pushed the weapon to the very limits of its design specifications. The massive gun was elevated to an angle that seemed impossibly high for the target distance, but Rebecca's calculations demanded precision in every parameter. Gun ready, the crew chief reported. Rebecca watched her computer screen, where a countdown timer showed the optimal firing window based on atmospheric conditions and Earth rotation. Fire in 10 seconds, she announced, her voice calm despite the magnitude of the moment. 5, 4, 3, 2, 1, fire! The M777 howitzer erupted with a thunderous roar that seemed louder than any of the previous shots. The increased propellant charge created a massive muzzle flash and sent a shockwave across the firing line that rattled equipment and shook the ground beneath their feet. The projectile disappeared into the clear desert sky, beginning a ballistic arc that would carry it higher and farther than any shell fired from that position. Rebecca's calculations predicted a flight time of 2 minutes and 17 seconds, longer than anyone had ever tracked an artillery round at Yuma Proving Ground. Time of flight, 2 minutes 17 seconds, Rebecca announced, starting a stopwatch. Colonel Drake positioned himself at the observation post with high-powered optics trained on the distant target area. Other personnel throughout the proving ground stopped their activities to watch for the impact of what everyone understood would be the final attempt of the day. 1 minute remaining, Rebecca called out, her eyes fixed on the timer. The desert air was perfectly still, creating ideal conditions for observing the distant impact. Through his optics, Drake could see the decommissioned tank that had served as their elusive target throughout the morning's failed attempts. 30 seconds, Rebecca announced. Master Sergeant Hernandez stood beside her, watching the countdown with a mixture of anticipation and skepticism. In 15 years of artillery service, he had never seen anyone attempt such an unconventional approach to long-range fire. 10 seconds, 5, 4, 3, 2, 1, impact. At precisely 2 minutes and 17 seconds after firing, a massive explosion erupted directly on top of the distant target. Through his optics, Colonel Drake watched as the decommissioned tank disappeared in a cloud of smoke and debris that confirmed a direct hit. The firing line fell completely silent for several seconds as the implications of what they had witnessed sank in. Rebecca had accomplished something that veteran artillery specialists had declared impossible, using methods that challenged fundamental assumptions about weapons capabilities. Direct hit, Drake's voice came over the radio with unmistakable amazement. Perfect target impact. Specialist Sterling. That was the most outstanding piece of gunnery I've ever witnessed. The artillery crews erupted in cheers that echoed across the desert proving ground. Master Sergeant Hernandez turned to Rebecca with an expression that mixed respect with disbelief. Sterling, how did you know that would work? I didn't know for certain, Master Sergeant, Rebecca replied honestly. But the mathematics suggested it was possible if we treated the problem as orbital mechanics rather than traditional ballistics. Staff Sergeant Torres approached with obvious admiration. Specialist, you just broke every range record for the M777 system. That shot is going to be studied at artillery school for years. Word of Rebecca's impossible shot spread throughout Yuma Proving Ground within hours. By evening, her firing solution was being analysed by ballistic experts at Army artillery centres across the country. The techniques she had developed represented a fundamental advancement in long-range artillery theory. General Morrison arrived at the proving ground the following morning to personally debrief Rebecca about her methods. The conversation took place in the Fire Direction Centre, where Rebecca demonstrated the aerospace ballistic software and explained her approach to extreme range calculations. Specialist Sterling, the General said, your firing solution achieved something that our weapons experts believed was physically impossible. How do we incorporate these methods into standard artillery doctrine? Ma'am, the techniques require advanced mathematical modelling and real-time atmospheric data that isn't available at most artillery units, Rebecca replied. But the principles could be adapted for specific applications where extreme range is required. General Morrison studied the complex calculations displayed on Rebecca's computer screen. Specialist, I'm recommending you for immediate promotion and assignment to the Army's Artillery Development Centre. We need to understand how your methods can be applied to other weapons systems. 3 months later, Rebecca was promoted to sergeant and transferred to Fort Sill, Oklahoma, where she began working with the Army's top artillery researchers to develop new firing doctrine for extreme range applications. Her aerospace approach to ballistics became the foundation for advanced artillery techniques that extended the effective range of multiple weapons systems. Colonel Drake submitted a detailed report describing Rebecca's achievement, which became required reading at the Army's Artillery Officer course. The firing solution she had calculated was designated as Sterling method in official doctrine, marking the first time in decades that conventional artillery theory had been fundamentally revised. Master Sergeant Hernandez, reflecting on the day's events during his evening report, told his wife, 20 years I've been doing this job, and today, a kid straight out of basic training taught me that everything I thought I knew about artillery was just the beginning. The decommissioned tank that had served as their impossible target remained in the desert, marked by a crater that became a landmark for subsequent artillery tests. New artillery officers visiting Yuma Proving Ground were told the story of the day when advanced mathematics made the impossible shot possible. Rebecca continued developing artillery theory at Fort Sill, where her methods influenced the design of next-generation weapons systems and targeting computers. But she never forgot the lesson she had learned in the Arizona desert. that the most significant breakthroughs often come from questioning assumptions that everyone else accepts as absolute truth. From the sun-baked firing line where 12 veteran gunners had failed to the research laboratories where her innovations shaped the future of artillery, Rebecca Sterling's story became a reminder that expertise without curiosity is limitation, while curiosity without expertise is just wishful thinking. The combination of both, however, can shatter any barrier that mathematics declares possible. Because sometimes, the most powerful weapon isn't the cannon. It's the willingness to calculate what everyone else assumes can't be calculated. And sometimes, the longest shot isn't about distance. It's about seeing farther than anyone thought possible.